His bird weighs 40 grams, less than a chocolate bar, and it is capable of spending 10 months in a row in the air without a single landing. Neither on a branch, nor on a wire, nor on the ground. It eats in the sky, drinks in the sky, sleeps in the sky, and dies in the sky too. Welcome to the Wild World channel. If you are interested in the wild world, subscribe right now. New videos about animals and nature come out here every week. Today we are talking about the swift, a bird you have heard hundreds of times, seen every summer, but almost certainly do not know. Because the swift is not just a bird. It is a creature that has rewritten all the rules of how it is even possible to live. Let's start from the very beginning. Every summer, dark silhouettes with sharp crescent-shaped wings rush over Russian cities. A piercing shriek, a swift turn, and they are gone. Most people look at this and think, swallows. No, these are swifts, and these are fundamentally different birds. A swallow and a swift have absolutely no relationship to each other. The closest relative of the swift is not a swallow, and not even a sparrow. It is the hummingbird. Yes, that very tiny bird that hovers over a flower and drinks nectar. They look as if they are from different universes, but from an evolutionary point of view, they are close relatives. Nature loves such surprises. To be honest, I didn't tell them apart myself until I started looking into it. I looked into the sky and thought, well, swallows are flying. It turned out I had no idea who it was. How to tell a swift from a swallow if you see them in the sky. Look at the wings. In a swallow, they are wide, softly tapering at the base. In a swift, they are narrow, rigid, crescent-shaped, almost like a boomerang. The swift's tail is short. The body is elongated like an arrow. It does not flutter. It cuts the air. The size of a common swift is about 17 centimeters. Weight is about 40 grams. The plumage is dark brown, almost black against the sky, with a pale spot on the throat. Externally, the male and female do not differ in any way at all. Even ornithologists determine the sex only upon close examination. Now, let's look at its anatomy, and it will immediately become clear why this swift is the way it is. Every part of its body is the result of millions of years of evolution, sharpened for one task: flight. The wings, narrow and rigid, are ideal for fast, energy-saving gliding. The bones are light but strong. The heart and lungs are adapted to constant workload. The metabolism is fast, efficient. It burns energy and immediately replenishes it right in the air. And now the feet. This is where the most interesting part begins. The swift's feet are tiny, 4 toes, all pointing forward. They are not for walking, not for jumping, only for clinging to vertical surfaces, rocks, walls, crevices, and buildings. On flat ground, the swift is helpless. It cannot take off from a flat surface. If it falls, in the best case, it will crawl a few meters. The only exception is the black swift, which can jump up and thus take off, but most species cannot. The ground for a swift is not a place of rest. The ground for a swift is a trap. The scientific name of the swift genus is Apus, translated from ancient Greek as footless. Greeks looked at this bird thousands of years ago and saw what we see: a creature that looks like it has no legs, a creature that belongs to the sky. Now let's move on to what makes the swift truly unique, to that record, which, when I learned about it, seemed like a mistake to me. I went to check it across several sources. It turned out to be true. A swift can spend 10 months in a row in the air without a single landing. 10 months, almost a year. While you live your ordinary life, wake up, eat, go to sleep, get up again. This bird the size of a palm is flying. It flies over mountains, over deserts, over oceans, it does not land for a single second. For decades, biologists suspected that swifts were capable of this, but it was impossible to prove. The bird is too fast. The routes are too long. Everything changed when Swedish scientists from Lund University developed miniature sensors, tiny backpacks weighing a few grams with accelerometers and light sensors. Small enough not to interfere with flight. The birds were caught during the nesting season, fitted with sensors, and released. A year later, they were caught again, and the devices were removed. The data turned out to be stunning. Some individuals spent more than 99% of their time in flight. Some did not touch the earth at all from the moment of departure to their return. Not once, not for a second. Did you know that swifts spend almost their entire lives in the air and do not land for months? Write in the comments who already knew this, and who was surprised by this as much as I was. How is this even possible? The swift does not fight the air. It uses it. Rising thermal currents carry it forward while the muscles work in a steady, stable rhythm. In good weather conditions, it can cover huge distances with almost no strain. In difficult conditions, it switches to active flapping, but never stops. And now the most difficult question. If a swift does not land for 10 months, how does it eat? How does it drink? How does it sleep? The answer to each of these questions is a separate story that turns upside down the idea of what is even possible in nature. Let's start with food. The swift hunts what ornithologists call aerial plankton. It sounds beautiful, and it really is beautiful. At an altitude of 1 to 2 kilometers above the Earth, invisible clouds constantly exist. The smallest flying insects, tiny spiders on cobwebs, tiny midges. The wind lifts all this up and carries it across continents. We don't see this. The swift sees it, or rather, feels it. It flies through these clouds with its mouth wide open. The bristles along the edges of the beak work like a net, directing the prey inside. In a few hours, one bird catches thousands of insects, from the smallest midges to small moths. When a swift feeds chicks in the nest, it collects insects into a special lump, a dense capsule right in its throat. Sometimes several hundred individuals glued together with saliva. It carries such a capsule to the nest and gives it to the chicks, a small, compressed, nutrient ball of life. With water, it is even more elegant. The swift does not land near a body of water. It flies over a lake or river at low altitude, and in a fraction of a second, touches the surface with the lower part of its beak, a thinnest film of water, and it gains altitude again. It bathes the same way. A light immersion on the fly, then it shakes itself off right in the air. Personally, this caught me the most. I am used to thinking that sleep is a bed, silence, a pillow. And here, a bird dozes at an altitude of a kilometer, flying over the Sahara. How a swift sleeps is still a subject of research. But scientists, studying related species and analyzing flight patterns, came to the conclusion. The swift uses the so-called unihemispheric sleep. One half of the brain dozes, the other remains active and controls the flight. The same mechanism is found in dolphins and some marine birds. Nature came up with it for those who cannot afford to completely turn off. At dawn and at sunset, swifts rise very high. They describe slow spirals upward. The air is calmer there, fewer obstacles. It is there, most likely, that the main part of sleep occurs. The bird glides in a stable current. One half of the brain rests. And that's enough. And the last thing, something that seems completely impossible. Mating. Observers have recorded pairs of swifts engaging in mating flights right in the air. A brief, rapid connection at speed, and again in different directions. For a creature that is almost never on solid ground, even this obeys the laws of the sky. Now let's follow one specific swift through its whole year. This will help to understand the scale of what we are talking about. Our bird hatches in a nest under the tiles of an old building somewhere in Europe. For several weeks it knows only darkness and the sensations of its parents arriving with food. Each visit is a capsule of insects, tiny wings and legs glued together with saliva. This builds muscles, forms feathers. One evening, the parents stop returning. Hunger and instinct push the young swift to the edge of the nest, and it falls. This fall is its first flight. No rehearsals, no experience. The bird has never seen the sky in its life, and in the very first second, finds itself in it. Almost immediately, it joins other young birds, and together they rise higher, fly around the city, and set a course for the south. Ahead is the Mediterranean Sea, the Sahara, Central Africa. A path of thousands of kilometers, without a map, without parents. Navigation in swifts is innate. Young birds find routes on their own, without anyone's help. Have you noticed swifts over your house? Write in the comments. It's interesting from which cities people are watching this video. The swift flies at an altitude of 1 to 2 kilometers. Radar studies show it rarely descends enough to be seen from the ground. It rushes over mountains and deserts like a shadow. By autumn, it reaches the warm, insect-rich air over Central Africa. Here, it will spend the northern winter, flying over forests, savannas, swamps, never staying at any single point, never landing. Months later, when the angle of sunlight changes, when instinct says it's time, the bird turns around and flies back north, to the same country, to the same city, often to the very same building, into the same crevice under the tiles where it hatched. During this year, it will fly tens of thousands of kilometers. Some estimates call it a figure of 40,000. This is more than the length of the equator, a body weighing 40 grams, describing the circumference of the globe. But let's go back to one point that I want to look at in more detail, to migration. Because when you begin to understand what exactly happens during this flight, the scale becomes even more incredible. Swifts nesting in Scandinavia set off for Africa at the end of summer. Their path passes over the Alps, then over the Mediterranean Sea, then through the Sahara. The Sahara is more than 5,000 kilometers wide. There is no water. Insects are extremely scarce. Heat during the day, cold at night. Sandstorms arise suddenly and turn the sky into an impenetrable wall. The swift does not fly around the Sahara, it flies through it. Over the tropical forests of Central Africa, the picture changes. There, the air is saturated with insects. It is warm there. There, the swift will spend several months, continuously moving over forests, over savannas, over swamps, never staying in one place, never landing. And then a U-turn. Birds from Scandinavia return to Scandinavia. Birds from Russia to Russia. Birds from your city to your city. This navigational instinct is so precise that researchers record the return of a specific bird to a specific crevice in a specific building a year later. Not to a similar place, to the very same one. How do they do it? Science does not yet have a full answer. Most likely, a whole set of mechanisms is involved. Orientation by the sun, by the Earth's magnetic field, by the stars. Young birds flying for the first time orient themselves without anyone's help. The navigation program is built into them from birth. This is not something that can be taught. This is something that just is. Now, one more detail that I want to note separately. Speed. A common swift in horizontal flight develops a speed of about 110 kilometers per hour. Regularly, not at the limit of its strength, just in normal cruising mode. The white-throated needletail, one of the largest representatives of the family, is capable of accelerating up to 170 kilometers per hour. This is faster than most cars drive on the highway. A small bird in 1 second flies a distance 150 times its own body length. If a human moved at the same relative speed, he would need the speed of a jet aircraft. At the same time, the Swift is not just fast, it is maneuverable. It is capable of sharply changing direction without losing speed, instantly soaring up or diving down. The secret: in independent control of each wing. The left and right wing can make flaps with different frequencies. Due to this difference, instant turns occur. This is exactly what makes the Swift almost unreachable for predators. The peregrine falcon and the hobby are the only birds that can really try to catch it, but even they rarely succeed. The Swift simply moves to the side at the last moment, and the predator misses. In a flock, it is even more difficult. When several hundred swifts rush over the city in a dense group, a dark vortex of bodies, a shriek, swift turns, it is almost impossible to hit a specific bird. The predator gets lost in this vortex. By the way, this rapid group movement over the city, what we see on summer evenings, is called a kettle. Swifts gather before spending the night, rise high, and circle together in the air. This is their evening ritual, not just a game. Most likely, it is at this time that the main phase of sleep occurs. High up, in the calm air, together. Now let's talk about what happens in those few weeks when the Swift does touch the ground, or rather, the wall. The Swift's nest is a separate story. Unlike most birds, it does not collect material from the ground. Leaves, sticks, dirt, this is not for it. Everything that goes into building the nest must be caught right in the air. Thin fibers, down, feathers that the wind carries at a height. The bird glues all this with saliva. In some species of swiftlets, the nest is built exclusively from saliva. No other materials, only the hardened secretion of the salivary glands layer by layer. It is these nests, obtained in the caves of Southeast Asia, that go into the famous bird's nest soup, one of the most expensive delicacies of Eastern cuisine. Although it would be more correct to call it swift nest soup, because swiftlets are swifts, not swallows. The swift has very strict requirements for the nesting site. It needs height, so that it can dive down and gain speed during takeoff. It needs darkness and protection from predators. It needs the ability to freely fly in and out. Ideally, a deep crevice in a rock or in the wall of a building. Swifts choose a partner once for a lifetime. Absolute monogamy. One pair, one season after another, the same place. If you see swifts that return under the roof of your house every summer, this is most likely the same pair. Year after year. The female lays eggs, white without a pattern, both parents incubate. But unlike most birds, swifts can interrupt incubation. If the weather is bad and insects are scarce, they fly away for food for dozens of kilometers. The eggs or chicks at the same time fall into a state of torpor. The body temperature drops, the metabolism slows down. The chick can go without eating for a week and survive. This is another unique adaptation, an organism that knows how to wait. When the chicks become large enough and fledge, the parents fly away. And we already know what happens next. Hunger, the edge of the nest, a fall into the sky. The record lifespan of a black swift is 21 years. If birds spend 10 months out of 12 in the air over the course of 20 years, this is more than 160 months of flight, more than 13 years of continuous movement in one bird's life. A figure that is hard to believe. And now about what is happening to these birds today, and why it concerns us directly. Once swifts nested in the hollows of old trees, in crevices of rocks, in caves. Then man began to cut down forests, rebuild cities, And Swifts adapted. They moved into buildings, into crevices under tiles, into gaps between slabs, into unsealed holes in the facades of old brick houses. From the Swifts' point of view, all multi-story buildings are divided into two types: those in which you can equip a nest, and those in which there is no such possibility. In old brick houses it is possible. In a new monolithic house with a smooth facade, no. There is nowhere to catch on to. And now renovation comes. The old facade is lined with new panels. All crevices are carefully sealed. The colony of Swifts that lived in this house for decades disappears. The birds return in spring to their usual place and discover there is no more entrance. I live in a panel house. There are no Swifts over it. Now I understand why. In developed countries, this has already been realized. In Germany, Great Britain, the Netherlands, environmental organizations work with builders directly. There are special bricks for Swifts, blocks with a built-in cavity of the right size, which are immured directly into the new facade. Outside is an ordinary wall. Inside is a ready-made nest. The bird flies in through a small hole and does not know that this was done specifically for it. If the residents of the house, when voting for the renovation project, choose the option with Swift boxes, the colony is preserved. It works. Where this is done, the Swifts remain. There are activists in Russia, too. People hang special wooden Swift boxes under the roofs of houses, negotiate with management companies, write to municipalities. This is not romance. This is real work that gives results. Have you ever seen Swift boxes, or maybe even made them yourself? Write in the comments, it's interesting. But the problem is not only in the nests. There is another threat that is harder to see. The Swift feeds on aerial plankton, and aerial plankton is insects. And here begins a chain that affects all of us. Pesticides destroy insects in agricultural areas. Part of the sky literally becomes a biological desert. The Swift flies over it and catches the air. Nothing. Light pollution of cities disorients migrating birds at night. They are attracted to illuminated buildings and towers and crash against the glass. Climate change shifts the timing of the appearance of insects. The Swift returns from wintering according to its internal calendar, but there are no insects yet, or no longer. Its chicks are starving. For now, common Swifts as a species are still relatively common, but in a number of European countries their numbers have dropped noticeably over the past decades. A bird that seems so free, belonging to the open sky, is in fact closely connected with what we do on Earth. And here, I want to say something important. The Swift is not just a beautiful story about records, it is an indicator. Scientists use migrating species as living instruments for measuring the state of the planet. When a Swift arrives earlier or later than usual, it is a signal of climate change. When its routes over Africa change, it speaks of a change in the rainfall regime on an entire continent. A small bird that we do not notice carries in its flight information about the health of the entire Earth. In many European cities, there is a tradition. The first cry of a Swift over the street is perceived as the real arrival of summer. Not according to the calendar, according to the Swift. And when these cries quiet down earlier than usual, people notice it, even if they cannot exactly explain why it feels wrong. Maybe this is the answer to the question, why do we need to know about Swifts? Not because it is useful, not because it needs to be passed on an exam, but because when you understand who it really is, this dark arrow that flashed over your head and disappeared, you look into the sky differently. 40 grams. 10 months in the air. 40,000 in a year. 21 years of life, almost all in flight. First flight with closed eyes straight into the abyss. A partner for life. A nest out of thin air, glued with saliva. Sleep with one hemisphere of the brain at an altitude of a kilometer over a foreign continent. This is the swift, a bird that decided that it does not need the Earth. Subscribe if you haven't subscribed yet, and give a like. This is the simplest way to say that you are interested. Until the next video. Next.